This is the last part of our topic under simple harmonic motion, which we base on the while question and answer. Then the first question with me here is question number 8D 2016 theory part. Now the question says a body of mass 20 grams performs a simple harmonic motion at a frequency of 5 Hz at a distance of 10 centimeters from the main position. Its velocity is 200 centimeters per second. Calculate is 1. Maximum displacement from the main point. 2. Maximum velocity. 3. Maximum potential energy. Very simple. The first thing when you are solving a question like this, you write out the given. Then what are the given from the question? We have mass M is equal to 200. It's equal to 20 grams, which is equal to 0.02 kilo. Frequency F is equal to 5 Hz. X is equal to 10 centimeter. And 10 centimeter is same thing as 0.1. Velocity V is equal to 200 centimeter per second. You can see this is centimeter per second instead of meter per second. Convert this one by dividing this one by 100, which will give you 2 meters per second. So in that case, just look. Don't forget, this is our displacement, not maximum displacement. Then we are looking for maximum displacement from the main point. This is our value of x. Don't forget our formula in the last video. So our formula that relates all this together is V is equal to omega square root of a square minus s square. That's all. Then don't forget this omega. I said we can change it to either 2 pi f or 2 pi over t, depending on the question. Now in this question, f is given. So we change it to what? 2 pi f. That's why pi is given in the question to be 3.14. And g is also given. Therefore we have v is equal to 2 pi f, then square root of a square minus s square. Just substitute and make this one the subject of formula. Our v is equal to 2, then this one is 2 times pi, which is 3.14, times f, 5, then square root of a square minus x. Our x is 0.1, is 0.1 square. So at the end of the day, if you calculate, the first thing, just you can multiply this one, multiply the whole of this one together, then divide by this. First of all, bring this one. You have 2 divided by 2. This one will give you 6.28. 8 times 5 is equal to square root of a square minus 0.1 square. So at the end of the day, you find the square root side, you are going to get your a to be 0.12 meter. So our amplitude will be 0.12, and if you look at it, it's greater than this one. So this one is maximum displacement. This one is displacement from what? Equilibrium position. Then the next question is maximum velocity. You apply the amplitude. Therefore, V is equal to omega A. We have this formula too. Then you change it as well. V is equal to omega, that is 2 pi f multiplied by A, which is equal to 2 times 3.14 times 5 times A, which we have gotten from here. That is 0.12. That's all. So whatever you get from here, so you are going to get 3.77 meter per second. Then the next question there is potential energy. So in that case, maximum potential energy, PE maximum is equal to KE maximum. So the parameter to get KE is given, which is equal to half mv squared. Then what is V? Which is equal to half m, mass is given. V, we have gotten it. This is our V, that is 3.77 squared. Then substitute for a value of which is equal to 1/2 times m. Our m is 0.02 times 3.77 squared, 42 joule. So that is the end of this question. So the next question is, now we are moving to the second question, and our second question is 2005 number 11, the theory part. Now the question says, sketch a diagram of simple pendulum performing simple harmonic motion and indicate positions of maximum potential energy and kinetic energy. And we have done that too. So when you have a body performing simple harmonic motion like this, so when you display it here and release it, come back here, this, and go like this. So this place, this is where we have maximum kinetic energy, Ke, maximum there. Then this one, Pe, maximum. So this one, we have our V, velocity here to be maximum. That's why kinetic energy is maximum. So we have V maximum, which is omega A. But here, our potential energy is maximum. Therefore, velocity here is equal to 0. Why potential energy here is equal to 0. So what you just need according to the question is to indicate here and this place. Then the next question, question number 11b, says a body moving with simple harmonic motion in a straight line has velocity v and acceleration a when the instantaneous displacement x in centimeter from its maximum position is given by, so we have x is equal to 2.5, 0.4 pi t. Then the question says, where t is in seconds, determine the magnitude of the maximum velocity and maximum acceleration. So to get maximum velocity, you will rewrite this equation. Don't forget this one. The one that says x is equal to a sine omega t. A sine omega t. So this omega, you change it. That is a sine 2 pi ft. You now compare. So from here now, x is equal to x. Therefore, our amplitude A is equal to 2.5. Then the one of 2 pi f is equal to 0.4 pi. They will now say 2 pi f is equal to 0.4 pi. So pi will cancel pi. Therefore 2f is equal to 0.4. Therefore f is equal to 0.2. Is 0.2 hertz. So we have gotten our A, that is maximum amplitude. Then we have gotten our F. Then the question says maximum velocity. Now apply the formula for maximum velocity, which is V is equal to omega A. V is equal to omega A. Then substitute. This one means our 2 pi, change it 2 pi F. Since we have F, we have gotten F. Pi is given to be 3.142 here. Then F, we have calculated it, is 0.2. Pi, you know pi. Then multiply by A amplitude, which is equal to this. So substitute for A, substitute for F, pi 3.142. That's all. So at the end of the day, you are going to get your final answer to be 3.142 times 10 raised by minus 2 meter per second. Then the next question is acceleration, maximum acceleration. And don't forget our maximum acceleration A is equal to omega square A. Omega square A. Then, therefore, we have substitute for the value of omega, which is 2 pi f, 2 pi f, everything square like this, then multiply by what? A. So when you do this one, you substitute correctly, you are going to have 3.95 times 10 raised to power minus 2 meter per second square. That's all. Do it very well. So this one will give you this. Now, the next question, that is question number 11C, says a mass M attached to a light spiral spring is caused to perform simple harmonic motion of frequency. That's another question under that same question number 11. That is 2005. Spiral spring is caused to perform simple harmonic motion of frequency. Therefore, F is equal to 1 over 2 pi square root of K over M, where K is the force constant of the spring. Explain the physical significance of square root of K over M. What is the significance of this? It's very simple. We have done it. When we have force varying directly with X, we said this one means F is equal to Kx. Then this is what? MA. MA is equal to Kx. Therefore, A is equal to Kx over M. Then this A is what? Omega square X is equal to Kx over M. This cancel this. Therefore, omega square is equal to K over M. So this implies that omega is equal to square root of K over M. So what is this omega? That is angular velocity. Angular velocity. So the significance of this one is what? Angular velocity. This one is same thing as what? Omega. That is omega. Which is what? Change. Rate of change what? Angular displacement. Rate of change in angular displacement, or you call it omega. Simple. Then after that, under that C, we've got to say if M is equal to 0.3, if M is equal to 0.30 kilogram and K is equal to 30 Newton per meter. K is equal to 30 Newton per meter. That is maximum displacement. A is equal to 0.015 meter. That is amplitude. Calculate the maximum kinetic energy of the system. Maximum kinetic energy of the system. What we just need? Use what? The same formula. Maximum kinetic energy. That is P and Ke maximum is equal to half mv squared at maximum velocity. Therefore, this one gives half. Since v is not given, or you have now calculated it, we give multiply by m times v. What is our v? Our v is what? Equal to omega a. Omega a. Then you find the square of it. What this one r squared? So we are going to have 1 over 2 multiplied by m multiplied by omega squared a squared, where our parameters are now given. You can substitute for this one. You get this one. Because K is given, we know K, you can get this one. Omega is equal to square root of K over M. Then K is equal to 30. M is equal to 0.3. 0.3 square root of it. So this one will give us square root of 100, which is equal to 10 radian per second. So once you know your omega, you put it here. Or you can even use hundreds completely. That will serve as well. Square of omega. Put it here. Put your amplitude. Put your mass. So at the end of the day, if you calculate it very well, you are going to get 3.38 times 10 to the minus 3. So you are going to have 3.38 for this one. You calculate it very well. 3.38 times 10 raised to the power minus 3 joule. Then the next question is tension in the spring. Tension in the spring is force. Is force. So we have two forces acting on the spring. The first one is mg, the weight of the mass. Then the second one is what? Force due to what? Extension. Therefore, tension is equal to mg plus ke. Don't forget the force. From Hooke's law, force vary directly with what? E. Then our E is amplitude. So force now is equal to Ke. So this E now into what? A. Therefore, this one mg plus Ke. That's all. So when you add everything together and do it very well, so you are going to get 3.45 Newton. That's the unit of tension. So that's the end of the topic under simple harmonic motion.